Hello, this is James Lowenberg-DeBoer from Harper Adams University in the United Kingdom, and I'd like to share with you some work we've been doing on the economics of autonomous equipment for application of biopesticides. Certain characteristics of biopesticides make them a challenge for application. One of those characteristics is the volume of water required, which tends to be greater than that of synthetic pesticides, and then also the fact that biopesticides often must be reapplied because they have little or no residual activity. This work is part of a larger body of research that looks at the economics and the feasibility of autonomous equipment for a variety of crop production practices. As you're probably aware, there is an intense debate among researchers and technology developers about what will crop robots look like, what kind of design will be used, what kind of technology will they embody. On your left, you see a small, specially designed crop robot for spraying. On the right, you see retrofitted, relatively small-scale conventional equipment that was used on the Harper Adams hands-free farm. We chose to focus on the retrofitting small-scale conventional equipment scenario, as was done on the Harper Adams hands-free farm. We didn't look at robots developed for microspraying because they couldn't handle the kind of volume of water that was required for biopesticides. We also didn't look at retrofitting larger conventional equipment, which would have the water holding capacity, but which would raise safety and maneuverability questions, especially in the UK, where the countryside is densely populated and fields tend to be small and irregularly shaped. We also didn't look at contractor applications because at current rates, frequent reapplication would quickly erode profits. The analysis shows potential for autonomous equipment. The chart at the right shows the returns to operator labor management and risk-taking with alternative production practices. The yellow bars are conventional, the green are autonomous. The autonomous returns tend to be higher mainly because of lower equipment costs with more intensive use of smaller equipment. The operator time in this scenario is actually not that much different. Take-home message is that the volume of water required is a major constraint for biopesticide application with autonomous equipment. Even with the 10% human supervision time, operator time is an important constraint, and biopesticide product cost is an important factor for all kinds of farms.